I'm Max Guernsey, and I want to talk to you about primitive data types. It's very common for people to use primitive data types to model something that really should have some kind of structure or abstraction over it. For instance, here I have a complex number class that takes a floating point number to model the real component and another floating point number to model the imaginary component. But the multiplier for the imaginary component, I, isn't really modeled anywhere in any type. It's instead implied in this calculation here for multiplication. We have to assume that there's I in the imaginary component, and when we multiply them together, we change the addition into a subtraction. And it just kind of makes things a little bit less readable, a little bit less explicit. And furthermore, it also makes it so that when you construct an object in this case, or if you were passing parameters into a method, it's not as clear what's being passed in. Yes, by convention, since we happen to be looking at complex numbers, we know that the real component usually goes first and the imaginary component goes second. But because they're both floating point data types, it would be easy to accidentally transpose them if you weren't paying attention or thinking about it, or if you're vibe coding or whatever, right? So let's look at how we can actually address this. I'm going to use ReSharper. You can use whatever refactoring tool you want. You can even do this all by hand if you prefer. Because I'm using ReSharper and I know ReSharper isn't very good with implicit constructors, I'm going to change to an explicit constructor. And then I'm going to use transform parameters. Some IDEs call this introduce parameters object. It doesn't really matter what it's called. What matters is what it does. What it does is create a new class that is used as a bucket for parameters that were passed into a method, a constructor, an indexer, whatever. So let's take a look at how that actually works. You choose which parameters you want to use in the new object, and you give the new object a name, and then you let the refactoring go. And you can see it goes and creates a new class. In this case, I called it real, so it created a real class. And it replaced the parameter. In this case, I only chose one parameter, so it replaced the real component parameter with an instance of this real class. And if we go back and we look at the client code, we can now see that instead of just passing in the number 2, we're passing in the real number 2. Okay, let's do that again. So now I'm going to do the same thing. I'm going to transform parameters, and in this time, I'm going to make it the imaginary number class. And then I can clean this up a little bit. Now I have a complex number that takes a real number and an imaginary number. So I'm just going to do a little bit of cleanup. Once I have a class called real, all I really want is the value. I don't need R again. And the same thing goes for I. So the imaginary number has a value. Now this doesn't make the logic any more explicit than it was before, but it gives me an opportunity to do so. For instance, I can start, now that I have an abstraction around real numbers and around imaginary numbers, I can start to add logic to them. For instance, I'm going to add the operator for multiplying an imaginary by a real value, and that just produces a new imaginary number. I could also add another operator that multiplies two imaginaries. And this will take into account the fact that I is a coefficient here. And we can say minus left dot value times right dot value. Now you could say, oh well, you're still not modeling I. You're implying it in this imaginary number, and that's true. I mean, that is true. We could pull I itself out and model it, but the point here is just to show a slight transition in the direction of encapsulating primitive data types behind abstractions. So we've got this new, better interface. You have to create a complex number with one real number, one imaginary number. We have an imaginary number that has some functionality we could use to do some refactoring. Maybe I'll show that later in another video. The last thing that I really would want to do is make it so that I'm not just going back to using primitives in this complex class. So let's take a look at how we'll do that. I would encapsulate this field that produces a property down here. And I know that property always has the same value, right? So all I need to do is make a new field. We'll call it real. Yeah, I should have made it read only. And now I can use that field, and then I can just take this expression and put it in this property. Once I've done that, I can inline the property. And then I could repeat that process. So we'll encapsulate the fields. We will make a new field for the encapsulated data type. Introduce fields. That's what I wanted to do the last time. We'll add the this to imaginary. And then we'll take this expression, put it in the property, and inline the property. Now I can go back and get rid of these fields. They're no longer necessary. And I can rename these to R and I if I want to. I wouldn't necessarily want to in real life, but in a video I might. Okay, so now I have completely removed the primitive data types from here. Later in another video, I'll show how to move kind of all the logic into those encapsulating data types, those abstractions over real and imaginary numbers. But I think this video has shown enough. The point here is we take that primitive data type, we move it out of our code, we put it in one place. It's not that you can't use the primitive data type. There's no way not to use primitive data types. But at least we can build an abstraction over it that serves as a reasonable place to put logic that is related to that element of our domain. All right, I'm Max Guernsey from Prodicore. Thank you.